Okay, so this is your test review. I'll try to make it as quick as I can. So first thing is we're going to cover factoring, solving quadratic equations by factoring. And so the first thing you want to do is make sure that you get it into the right format. So we want it to say not just y equals ax squared plus bx plus c. We don't want it in this format. We want it to say 0 right here, not y. The reason is because we're trying to find the place where this U-shaped graph contacts the x-axis. So we're looking for this point and for this point, if they exist. And so first things first, we want to have this equation say k squared. We want to move this piece to the other side, so that will change its sign. And so now it's going to be plus 4k. And then we're going to move this piece as well to the other side. So it's going to be plus 4, and then what's left on the other side now is 0, okay? So we've put it into the correct format where y is equal to 0. That's what's going on at this point and at this point. So now we're going to use our x method. The x method looks like this. We just make an x. We put the b term, which is the sum. That sum goes on the bottom, okay? And then the product, that goes on the top. And if this number out front right here is 1, then it's a very simple solution. We're just looking for the factors of 4 that could add up to 4. So for example, 2 times 2, if I use those two factors, then they would both add to 4 and multiply to 4. And so I can use 2. And this is what I do with those numbers. These two numbers, 2 and 2, I'm just going to place them into binomials like this, k plus 2 times k plus 2, like that. That equals 0. So you can see now that this is a perfect square trinomial, actually. And so it could be expressed like this, k plus 2 squared, right? You know that from completing the square. And so now at this point, there are two solutions. There's k plus 2 equals 0. Remember, the zero product property says that if this part times this part equals 0, then this must be equal to 0, and this must be equal to 0. So k plus 2 equals 0 and k plus 2 equals 0. Those are the two solutions. Of course, they're going to come out to the same thing. So we just subtract 2 from both sides. And so we get k is equal to minus 2. That's the only solution there for number 4. All right, on to the next section. So the next section that we're going to cover on the test is square rooting, solving quadratics with square roots. So in this case, what we're looking at are quadratics that are missing their middle term. Do you see how there's supposed to be, or most of the time there is this middle term b, but in this quadratic, it's missing. So what we got to do is just put it in this format. We want to move this 2 to the other side so that it looks like this, x squared equals, if we add 2 to both sides, we'll get 17, 18, 19. All right, so this is x squared equals 19. And then finally, we're just going to square root. Why are we square rooting? Because if we square root, we'll get rid of this square. And so it'll just say x equals something, which is what we want. And it'll say x squared equals plus or minus the square root of 19. Okay, so that's solving quadratics using the square root. It's going to happen when you don't have a b term. Okay, this b term right here is missing. All right, last section. So we're gonna solve quadratics by completing the square also. So take a look at number 4. Okay, we've got n squared minus 2n minus 3 equals 0. To complete the square, this is the notion. We're simply going to start by moving this term to the other side. Why do we have to complete the square? Well, because there are some quadratics that simply cannot be factored. And this is for unfactorable quadratics. So we're going to move this negative 3 to the other side, and so you're going to get n squared minus 2n equals 3. And then you're going to add the half of this b term squared to both sides. So the original expression looks like this, n squared minus 2n, and then you're going to add half of that. Half of negative 2 is negative 1. We're going to add that squared to both sides. So equals 3, and again, we're going to add negative 1 squared to both sides. So at this point, you have just made a perfect square trinomial. This is a perfect square trinomial, and so it can be factored like this, n minus 1 squared. If you multiply n minus 1 times n minus 1, you will get this trinomial. So we've managed to factor this beautifully here. And now on the right-hand side, we're just going to simplify what's right here. It's going to be 3, and negative 1 squared is, well, positive 1. So this comes out to 4. And then finally, you're just going to square root both sides because we want to get rid of this square right here. And now it will say n minus 1 equals plus or minus the square root of 4. Well, the square root of 4 is 2. So you have two expressions, n minus 1 equals 2, and n minus 1 equals negative 2. So both are true, and both are solutions to this equation. So we're going to add 1 to both sides here, and so you get n equals 3. That's one solution. And then we're going to add 1 to both sides here, and so you get n equals negative 1 right here. And so those are the three categories on the test. I hope you found this helpful for your review.